Good morning, ladies and gentlemen of Ionogram scaling. So this is about SAO Explorer software. Let me organize myself a little bit. I have SAO Explorer with me on the thumb drive. So before going into a demonstration, let us talk a little bit about the other things that you can do, where to find the data. You don't have to install SAO Explorer to start doing your science. There are other ways of getting to the scaled information. There are 1, 2, 3, 4 that we will very briefly talk about. There is a Giro web portal at giro.uml.edu. I welcome everyone. There are plenty of resources for the ionogram derived data, ionograms also. There's a TID-based browser, rapid browsing software on the web. Yeah, okay. There is a fast car on the web, which is the access to the scaled characteristics. For robots, we have API, which means that you can periodically call us and download certain things if you are building a space weather system. There are data products for HF enthusiasts. Any radio ham operators in the audience? Hey. Yeah, so we have math computations, we have local weather charts, we have latest ionogram displays for those of us who would like to quickly see where are the best frequencies for talking to other radio HF enthusiasts. And then we'll talk about the SAO Explorer with the expert access, yeah, and the demonstration how to do it. Okay, so there will be a demonstration of scaling tips and tricks, and we'll start with the general ionogram editing skill with the SAO Explorer. It's no longer finding a value and writing it down. It's about highlighting the leading edge of the trace. So it's a different technique. It's not like it used to be many moons ago. Then we'll go through some of the useful keyboard shortcuts. So remember, your target is 200 ionograms a day. Don't do more. Yeah, don't listen to that gentleman there that's sitting there. He's doing probably 500. Yeah, because he is already 200. If you do 200, then you go to sleep, close your eyes, you don't see these ionograms in front of you, right? But 200 is a respectful number. You have to do ergonomize yourself, essentially, so that you do it quickly, you don't spend time. I will show you how to spend a lot of time scaling one ionogram, and then we'll go through different tricks how to do it faster. So first, of course, there's a button to run the artist, right, which helps in many cases. If you do not have automatic scaling available, just rerun the artist, and that's going to be much easier than the manual scaling. Forward, back, going from ionogram to ionogram. Essentially, during the hands-on session, you will become this creature with the 3 fingers on the left and the 1 on the top, and you will be like 200 a day. Okay, signal thresholding. Optimize your ionogram display because you don't want to go through too much interference. I'll show you how to do it. And zoom navigation is frequently useful as well. So there are 2 concepts for you to not lose your work. Because if you spend 3 hours scaling ionograms and lost them, that's not a feeling that I like. It is. Many of us went through that experience, and yeah, you would like to really crash your SAO Explorer workstation, and they are still useful. Don't do that. So save button is your friend. Okay, save. Just hit that button to save if you are working with files. If you're online with the database, please, just enable that auto submit. And when you go to the next ionogram, your previous ionogram is automatically saved for posterity in the database, which means connections go bad for some reason. You stepped out to have a coffee and came back, the connection is stale. You lost one ionogram, not 3 hours of your scanning, okay? Auto submit, very important. And then there is, of course, the contour plot, because it's some of these things, some imperfections that are really worth working on are very visible when you have one panel with the time series of the scale characteristics strategically. If you're working from home and you have to display two monitors, just place that contour plot on the left monitor, work with the right monitor as a scaler, and that is certainly will give you a comfort understanding that you are producing good quality manual scaled ionograms. Contour plot. Address subsystem. Anyone used address with the SIU Explorer? It's especially useful if you're working on conjunctions. I know there are a lot of interest. Ionograms are still one of the best ground truth reference of what ionosphere density is. Okay, bottom side, right? We understand that. So frequently you would like to compare it with other instrumentation, and then type it in locations and times becomes a nuisance because it's a long operation. You have to query one by one. So there is an address system, automatic data request execution subsystem. You just give them a list of stations and times, send it, and then you just go through one by one, and that list can be generated by conjunction algorithm. So say you would like to validate cosmic profiles, right? Where is that? Oh, there it is. Is our cosmic validator gold medal. So yeah, you don't really have to do the manual work of subsetting this data painfully and slowly. Okay, so quickly about things that you can do without SIU Explorer. This is homepage, giro.uml.edu. Everyone's welcome it. There is a subsection on the top with the errors showing ionogram data. Let me use my pointer there. Oh, it's not like I see the screen from that. Do you see that? Yeah, there it is. Oh, wow. This is a big screen. Okay, so that's where all the ionogram data is. Fast car, very welcome. For those of us into robotic calls with the API, these slides will be available, right, for the participants, right? Just plug in the station, which characteristics you would like, from which date to which date, and you got the expert, no SIU Explorer required, no need to click menus, just you can do it from within your software. Okay, rapid ionogram image browsing, that's new. Yeah, you're very welcome to it. Try it. It's you just have a whole list of stations, about 130 of them in our collection DID-base. Start with the selecting one of those stations here, then select the year, months, day, and then these buttons forward, backward, plus 1 hour, minus 1 hour. Just go through that today reasonably fast. It's going to be faster than the SIU Explorer, I would think. Okay, here's the MAF and the latest ionogram. Okay, this is latest ionogram for those of us who are into radio. Here's Marconi himself in his setup. He had quite a few of radio equipment units available for his work. So just say, oh, sorry, that was not intended. Okay, just say, call this script periodically give the Dorsey code, you will be seeing the latest ionogram. Okay, this is a local weather 24-hour chart, useful for those of, again, who would like to know what are the conditions of the ionosphere. Let's look at it. The horizontal axis is time. You're looking at 24 hours. These are the latest. Yeah, that's now time. Everything forward is a forecast. Everything backward is a result of the overlaying three different things. Green line is IRI, that's your quiet time expectations. This is a 4F2, right? That's what it should be if there is nothing going on. The blue dots there are the measurements coming from the system. This is Lua Lake. Do you know where it is? Hawaii. Yeah. Very suitably called Lua Lake. Okay, so the color here is used to indicate how confident is the automatic scaling, and you see there's actually a little bit of some outliers, but then something is starting to develop. This is the area where the ionosphere becomes disturbed. So if your task is coming from your seniors to quickly find problems, fix them, and give me results, this is one of your tools. You can quickly see when the ionosphere becomes disturbed by using that display. That's certainly all these lighter shades means the confidence of the autoscaling is poor. Some of the white ones are replacement of the values that were considered to be very unreasonable. And overall, from all this jitter and somewhat chaotic behavior, yeah, the situation is clear. That's the time where you would like to dedicate most of your efforts to fix. Okay, that's important. And the yellow line is our assimilative model that has certain protection against a data noise, right? So if you are into your space weather, that particular model, which is global model, yeah, which is useful. It filters out some of the finer detail, no TIDs. This model will not show you TIDs. TIDs are the faster variations, right, Siva? Yeah, Siva is our TID expert for the medium scale. Yeah, welcome. Yeah, so that model will not represent the medium scale TIDs. You have to use a different sounding technique, not ionograms, in order to get them in this chart. Not the, no, let me say it again. You can use ionograms to see medium scale TIDs, of course, what I'm saying. Of course you can. It's that that model will not give it the medium scale TIDs information to you. Okay, popular local weather charts. Other ham radio tools, these are the math computations. Just plug in whatever distances you would like to, because you already know who you would like to talk to. You know the distances, just plug them in. You get your maximum usable frequencies. And then there is SAO Explorer. Okay, switching to that topic now. Okay, let's look at this again and again. Question, is this day or night? Yeah, simple question, right? Day, right, day. Because there is no E layer in the night, right? If you see E layers, that's day. Why there is no E layer in the night? Where it's gone? Do you know? Yeah. Okay, right, there's no sun, so it disappears. Why there is a F layer? Right, because the dynamics, plasma transport, so all these things. Why I'm telling you that? E layer and F1 layer basically controlled by sun, basically. Well, there are, of course, some funky eclipses and all other things. So please, please, have a look at the predicted FOE. Have a look at predicted F1, FOF1. Because if you are not clear where this E layer, where is that F1 layer, that would be your information. You can quickly sometimes tell if the little wiggle in your trace is actually not F1 layer, but it's a TID passing by. Okay? F1 predicted value comes with the probability of F1 existence. Very important. Yeah, just like Mikhail was explaining to us that there is a condition when the trace is not well defined. You can look at and see, is there even a probability that F1 should be there? If probability is low, you don't have to scale it. Okay, F1. One of the greatest challenges there. Okay, let's keep going. Well, there are crystals like this, right? You put a crystal and your image becomes double. So there are two polarizations. We use red color for ordinary, okay? Green color for extraordinary. By convention. I didn't invent it yet, but when I see the other coloring, I am confused myself. Yeah, sometimes, yeah. Okay, ordinary red. Your interest is ordinary component. You don't have to spend time on the extraordinary. Okay. So again, you don't have to scale numbers and write them down or type them in the Excel or somewhere else. You need to highlight the bottom part of this trace using mouse pointer. That's the task. Okay, I just have a couple of slides left, except that I seem to be somewhere. Okay, I think I'm back. Okay, I'm back. Right. So you know why the virtual height is larger than the real height. Of course, signal reflects somewhere, but because of the wave traveling less at the velocity less than speed of light, it slows down in the ionosphere because of plasma. Yeah, we are overestimating the height. So there is a process called inversion. This is your responsibility. You need to run the process of computing the real, well, not the real, they call it true, the true height of the reflection for every signal. Okay, that there's a button that you need to use. Why is it called inversion, not conversion? I think I knew that answer once, but I forgot. Yeah, why is it inversion? Yeah, it's inversion. Process of inverting the observed virtual height to a real height of the reflection. Okay, so what do we want from DID-base? That's the philosophical. Yeah, search, locate relevant data, access data quickly, trust that the data quality is high. If data are missing, incomplete, if you're wondering if the data is incomplete, that's not good. That is our responsibility so that you have confidence that the DID-base collection is complete for the experiment that you are running. You don't want to wait for a long time. We are working on it. But yesterday I tried to do SAO Explorer from my hotel room. Not good. Yeah, we will be working with files today, unfortunately. Yeah, it's kind of, you wait for too long for the ionogram to be moved to your computer over the internet. Software bugs, unfortunately, they are there. So save button is your friend, and auto submit in case you are connected. If you have a great connection from office and you feel comfortable working with the online database, that's good. Data errors, auto-scaling blunders, that's where you should shine on. Find them, fix them, send the manual scaling to me, They will be preserved with your name attached to it. That's your scaling results. We like every single ionogram. Okay, before going into SAO Explorer, let me just say one thing, is that there is a possibility of configuring DigiZone that we will be working on into what is called the high accuracy or precise group height. That's a special technique that allows to go into sub-kilometer accuracy and precision in evaluating the arrival of the time or distance to the target. Yeah. Why is it important? Because you can avoid errors just because it's not clear where to put that line. When you have a mouse pointer and you would like to scale an ionogram, yeah, where do you put it? We usually say leading edge, but as you see in this particular example, do you see yellow line from the audience? That would be the leading edge. That's what we used to recommend. But if you use the precision group height mode, that's the white line. So actually, here you go. You have been just mistaken by about 7 kilometers. Yeah. Is it much? Maybe not that much. But yeah, why not? If it, just please use it. And now let me go into a demo. Oh, I'm sorry. Yeah, the operator in the back. Can I remove one of those guys here? Okay. I just removed it. Yeah. Thank you. I just removed it for the thumb drive that I wanted. Okay. It's going. Can I have this screen? Yeah. Beauty. Thank you. I still have mouse, which is great. Okay, so I started the SAO Explorer. And there are buttons on the top where you can open the file, right? So I am looking for a file on my thumb drive. Okay, it opened something, right? How many you see? Total records 1. So I open one file, one ionogram. Which station? Point Arguella. That's California. Okay, nothing there. No value, no value. It's only an ionogram. So what do we do next? We click on the button ionogram. Okay, here's the ionogram itself. Is it day or night? You are quiet today, all right. Okay, so this is night, of course. There's no E there. There's a little bit of something at the bottom there, probably oblique, look oblique. How do I tell it that it's oblique? You remember the red color is O, the green color is X. Other shades of blue and everything are oblique. If you look at this button here, you can remove oblique. See, like this. So you're looking only at the vertical part of it. Okay. So we need to scale this ionogram. This is F. To layer. At the bottom, I'm saying add F2. Right? Add F2. Ooh, these are boundaries. You have to place them at the ionogram trace. The way you place them, you use your pointer and drag it. You don't have to hit that little circle at the bottom. You just do it like this. See what I'm doing, right? And this one. That's your first step. You identified where the beginning and the end of the trace is, and then you just do it with your mouse pointer like that. And your task is done. You do not have to be very careful. Okay, that's the button that I was talking about. Let me see. You see that snap to PGH? See that will become thinner. Let me use the button. Okay, I promised you to show the buttons, right? So the buttons 1, 2, 3, and 4 are applying different level of removal of the background noise. See, this is 1. Well, there's also 0, which will be like everything is shown there. Okay, 1, 2, 3, 4, 5. So you progressively threshold more and more of the data. Plus button, I hope it works here, is zoom in, minus zoom out. The arrows work. Okay, you can go. Plus, 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 plus. You can look at the, you see the data labels there on top? You can look at the precision heights values. Here they are. These are the, you see all that echo here, 3 of them, comes from 274 kilometer mark. So if you snap, that becomes a very thin line. Okay. Useful. Why it's useful? Because it's accurate. It's a special technique that doesn't care how your zero reference is calibrated. So that's it. That was your first step. Escape button brings us back to the full natural zoom. Any questions so far? More questions? Okay. So your hand is on the ZXC because you're going through the data. The C on the key runs the profile inversion. Remember, profile inversion is your ultimate goal. That's the information precious. Nobody well, incoherent rater can do it, right? We understand that. Yeah, but these are unique instruments. They don't operate all the time. Yeah, so hit C button. Here's your profile inversion. That's it. You can go to the next one. Let me undo that, which means I will lose all my careful scaling of the trace. Undo, blank, and hit the F10 button. F10? Is there F10 here? No, it's something else here. Okay. Artist button is on the top also. It's F10. So W. Okay. So you see, actually, that's pretty good. You don't have to manually scale. Tobias, I'm sorry. Was that your intention that everyone scales manually?
Yes, please to begin with. But continue your explanation.
My apologies. Yeah, I just violated the original gentleman agreement that everyone learns how to scale them manually. Yeah, F10 will give you a quick. Well, for some reason it took a little bit longer. I think this is high resolution. Nexion, yeah, it's a Californian Nexion. They use high resolution there, so it took longer, a little bit more complicated. But usually it's a few seconds, and you get the artist result. Okay, but look at the quality of that plus button, plus. Yeah. Oh, that's the second hop. So the artist goes through the precision group height very nicely. So that's the best quality. Otherwise, do not spend much time trying to making these wiggles here very accurate. It's not that important. It's not. The most important part is this. Your last few points next to the critical frequency are critical. You change them even a little bit, you will get slightly different peak height of the F2 layer. You remove one, let me show you, just remove a couple of points, rerun the profile. The profile you see, that's the profile, it's significant difference. If I do all these crazy things here, rerun the profile, no difference, okay? Do not waste your time beautifying the little jiggles and wiggles there. Yeah, spend time carefully looking at the critical frequency. How to do it here? There's a little bit of spread going on. You see, it's not a thin line, right? How do we deal with that? Well, I'm perfectionist myself, so let me straighten up again or rerun the artist while I'm speaking about it. So are you going to be talking, David, about the spread, right? You will. Okay. I don't want to preempt you, David. He will explain how you're fine with this. Okay. Essentially, there is a frequency spread and a range spread. So the frequency spread is you would like to put your line at the left boundary of that cloud of echoes, at the left boundary here, right? Because the other ones are a result of coming further. It's a spread in frequency domain. They are coming not vertically. Your task is to find the vertical echoes, okay? So, and then you somehow go back to the leading edge. That's the ideal scaling of the slightly spread trace. Let's open another ionogram. I can add files or open a new one. I think the first one was the daytime. Let me see. Yeah, that's the daytime. Okay, let me do a full-fledged manual scaling, no artist included. Okay, so we start with add E-layer. And E-layer is gone somewhere. Okay. Did I click it? No, I didn't click. Add E-layer. Oh. Oh, interesting. Learning something every day. Okay, I did something that for some reason. So what I did undo. I think something that I did by mistake. Yeah. Okay, so that's the layer. Let me click snap to PG. Oh, it's already clicked. So the that's the high accuracy. That's the layer. All right, it's not quite. Then I'm adding F2 layer first. I'm adding F1 layer second. And the C button is your magic friend. Compute profile, done. That is a daytime, relatively simple. So you see, if I correct these little things, like this one, correct a little bit, no difference. I'm keep hitting C, it's the same profile. That part is important. You see, yeah, you can possibly spend a little bit more time making that. You see, that's the more important part of your scaling. Questions?
What about the frequency band in which you didn't draw any trace between 2.88 and 3 megahertz?
That's fine.
Doesn't matter. Try. This is fine for you?
It's fine. Yeah. Yeah. It is frequently the case, especially when there's a strong F1, well-defined layer, there's a gap between them. Now, we don't try to fill the gap. We don't. There are other situations when signal is not that good. Sometimes one of the cusps is not well defined. It's shorter than the other one. When I say shorter, means that this one goes into a well like 700 kilometers. The other one may stop at the lower height. I would extrapolate to the same height as the other component. That I think is permissible. Otherwise, we did testing with the incoherent scatter radar. Usually, we do not extrapolate past the critical frequency what you see on the screen, unless you suspect that there is a signal loss because of the dispersion or something, something that makes your critical frequency cusp not well defined. But if the other one is clear, then we extrapolating to the same level of height. Your second hop can be useful when there is a spread F. The reason is, just think about it. You send the signal up, it goes back, up, and back. So second hop will match the vertical echo. Second hop will match the first vertical echo, first hop. Because if your first hop is slightly oblique, and therefore there's a spread, it goes up, down, up, and it walks away. You will not see it in the second hop. The signal goes out, okay? So in very strong cases of strong spread F, look at the second hop. It may be helpful in identifying where is that cusp of yours. Oblique button, other things, contour plots, save button, right? File, save. Save all SAO records. That's the one. Keep saving them, please. If you look at this menu here, you see the letter E is added, stands for edited. If you see that E, that means it's not saved. You walk away, you closed something, something crashes, that's your loss of your work. You should not shouldn't do that. Save button. Save button is useful. For example, I just save. Yeah, save all SAO records. Yeah. Then there will be I guess that's the save, right? Save, you see? You don't see those flags E anymore. If you worked and say which one I saved, which one I didn't, you look at that menu, you will see some of them were left unsaved. Yeah.
I'll just make a comment. You were talking before about people should use. So actually, if you can bring that menu back up, just to make a comment, Ivan was advocating the use of predicted values for FOF1 and FOE. If you want to know where they are, they're right here, right?
Right.
So if you have any doubt of what FOF1 or FOE should have been based off of effectively the IRI or something of that order, you can just look at this window to find that.
Yeah.
Sorry.
Another point, if they do not match for some reason, what you see on the ionogram and the predicted value, one clear possibility is that your sunspot number is old. So you go to our web page and download that file, sunspot.dat, or something like that. Refresh it from time to time, at least once a year, because the forecast of the solar activity has been notoriously wrong because of the unusual behavior of the sun. So if you are wrong about the expected sun activity, then you may see certain things. Well, we could talk a little bit about connection to Lowell. Are you interested?
I'm not going to use it anyway. No, we work in facts.
Okay, all right.
But they should know that it exists so they can do it themselves. We won't give them files forever.
Right, so one sunny day we put all our observatory to cloud storage, reliable, fast everywhere on the planet, backed by whatever the system replicators are across the whole world, and you will be working online with DID-base, which is a certainly more comfortable, in my opinion, experience. But I may stand corrected, so there are calls for not using database connection because of certain problems with the connection being dropped. Again, we are working on this slowly. This software is part by part is being migrated to a modern environment. We have connection pools that die hard. They will restore connection if it's broken. There are other things, a new visualization, and certainly it will be a much better system once that migration is done. But this is enormous work. We are talking about roughly 5,000 operators of Java code that you see on screen in action. Yeah. It's a big project. It's a big project. Now, I don't want to confuse you with any additional information. SAU Explorer is more than that. You can go to your profilograms, directograms, contour plots. You can look at the spread-F in action. You can see equatorial bubbles across in the station. This is not the topic of this tutorial, so I don't want to confuse you and giving you information that will distract you from your major task today. You should be able to install SAU Explorer, should be able to start it up, open ionograms, scale them, save them, and use the final product of your work as a ultimate 100% reliable ground truth reference for your comparison studies. Sounds like this is it for now. More about it during our hands-on sessions.
I don't know, when is the lunch break? Is it 12:20 or 12:40? If you can quickly let me know, you can give this for a second. Yeah. I mean, unless you want to say anything else.
No.
Leave this for a second.
Okay.
Because so we will now come to actually doing some scaling for you all. Who has a laptop with them where they have succeeded in installing the software and they have a mouse or a good? Okay. So those, I think I counted like at least 6 or so. Some people might also have it and not raise their hand. As we said before, you can work in small groups, so arrange yourselves, I would say. I will show you where you can actually get the data. One thing that I want to clarify additionally, because it might not have been entirely clear I mean, for us, this is trivial, but maybe if you've never done this before, you have to be aware there. Ivan said, like, save SIO files. So you will get the ionogram files, but these are just the ionograms themselves. And then there's a different file, which is this SIO file, which contains all the values that you actually scaled. Okay? These are two different things. We will give you the ionogram files, and you have to create the files with the scaled data. There will be Ivan, David, who is here, Mikael, who gave the presentation, myself. There's also Dan Kuba, who is a very experienced scaler, who is sitting in the back. You can ask us if you are stuck with an ionogram or you have a question, or there is something that certainly at the beginning you might have like just practical things about this that were explored that are not clear to us. Immediately ask us, please. We will then start arguing amongst each other about the details. For instance, I do not agree with Ivan's scaling of this ionogram. I think it's very clear that there's a sporadic layer here. Yeah, this is not all the E-layer. So if you put two ionogram scaling experts together, they will have 5 opinions on each ionogram. So yeah, that is what will happen for the rest of the session. So okay, arrange yourself in groups. I will then show you where you can. Yeah, this is your USB that is still here.
One more comment.
Yes.
If I can make.
Yes, please. I have a microphone here.
Okay. So the comment that I wanted to make, when you are done with editing the ionogram and you push the save button, there are 43 different things that you scale from ionogram, not just those 6 that we are working with you on. All of them will be elevated to the level of manually validated ground truth value, which sometimes means that you also overlooked scaling hidden ES layer, which is sitting below the regular layer, right? Which is here, if you look at it carefully. There's things like frequency spread, FF, FQ, which is not indicated here. You didn't put that number, it's gonna be no frequency spread if you want. So in the past we were trying to say that okay, if I didn't change the value from artist, then we don't consider it validated, something like that. We were trying to bring some schemes there, but we forgot to know. So everything that is available on that diagram with the numbers will be considered manually scaled validated value. Just be considerate of that responsibility. It's going to be used by someone.
Yeah. Okay. One final thing that I then wanted to say, because where is the SIO Explorer now? Here. Yeah. So as Ivan already mentioned during his explanation, you have a button up here where if you click that, the software will just do the scaling for you. And usually, certainly for the easy ionograms, which we will start with, the software is actually doing quite a good job. And so if you just open an ionogram and you click that button all the time, it will work like 99% of the time perfectly fine for these simple ionograms. But then, of course, you will not have learned anything. Right? So the idea is that you will start with trying to make the scaling yourself by just manually adding the 3 different layers, at least at first. For the complicated ionograms that we will do later, it might be worth actually running the software, because then you will see what kind of problems there is with this software. And that is one of the things that we wanted to clearly show to you during this tutorial, that if you use this software-derived parameters, that there are often all kinds of problems with these. So, have you all like a laptop or sit together with someone with a laptop
I think it's best if you work like with 2 or 3. If you want, you can of course also do it on your own. Now you can do 2 things to get the data. Either you have to go to this link. I don't know if this will work for you. For me, it would not work. But if you want, you can now take your camera and take a picture. Otherwise, I have made a link specially for you. If you go to this URL. Yeah. But I saw that you sent it, but I had already made one myself as well. Do I have a slash on this there? There is no thing like this. So ionosphere, what the hell? Meteo.be. So this is the website of my institute, ionosphere.meteo.be, and then ursi.html. This is a temporary page that I made, and you can click here on practical session 1, and that will take you to the place where you can download the data for this. So I have still Ivan's SIO Explorer here. So in case there is some ionogram that needs a lot more explanation from us, we can always put it up here. So that's why I think it's useful to leave this for the moment here. So I suggest that everyone or every group takes like an ionogram from their favorite, like takes the file from their favorite day and their favorite observatory. So the name of the file is always, there's first the code of the particular observatory. So for instance, this one is San Vito, this one is Nicosia in Cyprus and so on. And then there is the date. So if you take one of these files, it will contain 24 ionograms for the 24 hours. And then you can start with that particular day. I suggest that you just pick one of the observatories, one of the days, Michael, unless you had another idea of this. Unless you had another idea of how to do this. Not everyone needs to start with the same, right? So just everyone pick another day and another observatory, download that file, start your SIO Explorer, open that file. If all of that procedure already works, then you're ready to start scaling. If you have a technical problem, please raise your hand now, because otherwise you cannot do anything. If you don't have a laptop, join the person sitting next to you and work together. It might actually be interesting to do this with 2 or 3 people together, because that way you can like discuss among each other as well. Maybe maybe you don't need to ask us. Maybe you can find amongst yourself already more information than better ideas than what you would have on your own. So, is everyone ready to start working? Yes? Question? The link. I think I can. No, I cannot. Yes, I can. So it's ionosphere.meteo.be/ursi.html. Or you can use, if you are more modern, you can use this QR code. Yes. Yes, please. Yes, please. People who have the software available and someone can come with them to work, because a few people do not have it themselves. And like I said, it might actually be better to do it with 2 or 3 people in a group. So the people who do not have it available themselves, there are some more people here in the front. Please. Yes. So we have like 10 groups or something. Someone still looking for a collaborator? You can come here. Who is still looking for a collaborator and does not have the software?
And then you just pick one of the files.
Again?
Just pick one of the and download.
Okay, thank you.
Anyone having some practical problems getting to the data?
Without.
I wasn't sure if it was one of the things with Space Force transition or which transition that they maybe
Well,
change
we
that.
will be discussing that. There are 3 older stations
Successful one. I'm getting to it.
older
No, it's just not very fast.
and Australia.
These files are actually the ionograms. They could take quite a bit. They are quite big files.
Support of the station.
It's 24 hours every hour, which is actually the measurement. So they take up a lot of space. These are
So far, so good.
Again, the problem is having a sign up sheet that is just for everyone just starts up. Because they don't want to take a chance of actually. If we have to find shares, that's a problem. We can try to extrapolate to the data. Yeah, that's great.
So whenever you are ready with the 24 ionograms of one particular TN station, please raise your hand and one of us will come and then we can check whether you're doing a good job. Because of course if you just start scaling and you're doing something wrong, then you're already finished with one day? Okay. You can of course also raise your hand if you have a problem as well. Yeah. Okay, so
Yeah, we try to download maybe only one so I can see it.
That's a good question. So, in this case, of course, they are contacted.
So now you put them on. So you can just drag it. So where do you think it goes to?
Well, you can navigate wherever else you want.
Yeah. Yes, I would. And then the roll down. Put the then you, I cannot do this for you. You taste the slope just by yeah, so you just okay, so you did better. Well, actually, but that's because you can zoom. Yeah, I got like a system here. So you can as he runs also the main piece of story is also it's mostly it's actually if you're familiar I don't know touch so then because so now you can
Yeah, it's tough. It's actually this is something that hard and not easy. It's not really gas to deal with. Let's see. We jump across the gap. Yeah.
So now you have the entire and if you not now go you will see that here now all the values
So that gap
are now filled.
every ionogram.
So every two,
It's a persistent.
every one of those
There'll be gaps. There'll be gaps like that at all stations.
and the height is from what you put in
So you can actually see a lot of these boundaries and anomalies, right? So you see all of these different interference bands. What you'll just sort of into a scene.
well, the ones that
Lies off to that.
are a mixture of
Do that as an expected high interference
like 99% are scaled by and some of them scale by
So, but
if you just
generally, try to be aware, like, for example, just when I do
it's still the given
these situations not done for a lot of very flat still, that's not usually a structural explain even here,
which
still a
is
little
the
flat,
same sort of
but I think also this one is part of the say we're within 5%.
that's the name of
The second thing,
and then practice in this case like this. I actually took a mistake. Because I didn't mention there was 2 layers. So I said in that
when you're scaling, try to use the trace dimension C box because this is is the trace of the flat.
so
Always represent is usually a find out 8
so now you can go to the next slide.
when you start out, I'm just gonna move this over to the X one.
What's going to last?
So you need to see for the tethers. So the separation here is over. Right. So when
starts to change.
Where
this one, well, you can do that style, but just to get some experience. But this one, which is also stage, probably should be somewhere around here.
So it's just, there's a lot of little tricks just to get some experience. But just be suspicious.
You see the style,
It's too flat, or if the gap looks too big.
no. This is not good.
No, well, yeah. But the problem is that
I know what happened, and I have to explain.
I'm going to give another explanation which might be relevant because sometimes the ionograms, the way they are shown, are cut off. And this is because Ivan mentioned that you can zoom in and out, but you also can set here the limits of the frequency and the height, right? Because sometimes if you just go to the next ionogram, suddenly the trace starts to go off the screen. But that might simply be because you're only looking at like the up to, like if I put, for instance, this here up to 7 megahertz, or okay, that's still showing everything, up to 5 megahertz. Now all of a sudden you're not seeing where the FOF2 actually is, right? And so that's what's going on in that case. If you play the movie, but you only show to 5 megahertz, then the trace will during the day go off. Right? So be careful with that you make sure that you're looking at the entire ionogram. Okay. It should be plus and minus, but apparently it doesn't work on all computers.
You can also just use the form fill at the top.
Yes, this is actually what I always do. I just put in the limits that I want in frequency and height. Because if you use plus and minus to zoom, you zoom both frequency and height at the same time.
If the layer is particularly thick, and there's a large region where the gradient is very shallow, so you get a very long height. But if the top of the bottom of the ionosphere is you won't get as much.
Yeah, but you can also
Depending on, sorry, regardless, you know, just a tiny bit so often you'll miss pieces at the ends of the traces, or where you would expect these kind of bits. So those would be the most important. Sorry, to finish answering your question. Yeah, so you start to get a little bit of partial reflection.
now it is important that this part here is this you might
There's like mathematically
because that is what defines
in the absorption equation, expand out there's one that's a ratio.
well, actually, the moment you fix this, the moment you do the calculation, because
To answer your question, big latitudes, high latitudes, you actually might get the exponential entirely. And then latitudes you talk about, which is over again. And you have to be very careful because you have a problem over here that's Z is and your exponent is
now you know what is
so you still have two traces, but now they're in the wrong order.
but then you have to calculate.
High latitudes can be really a pain.
Because if you only have
The Zen mode is just a very, very specific case where you get some like
it's not this gold
where the signal is propagating directly.
Well, so the topics don't this software that is behind it.
No, it's not. Yeah, that's a problem. It'll be around.
So if I of course, if you have a major condition, it might be that the region around the peak is affected somewhat differently from what is currently they just fit in
The same orientation of the movement exposed left and right.
So yeah, yes, it's usually it works very well, especially around
so it changes.
but then of course
This way you get right circle polarized, that way you get left circle polarized.
but then of course there can also be a valley
That
between
that's the same.
and then how exactly the shape of that valley is, that might be, especially in the stuff
No, we're off this track. It gets max the two fixed problems. No, yes.
and actually if you look at the medical values, somewhere I can reach from my life.
It has to be, no, so it's there could be slight differences in the height. So the Zen mode,
So it calculates during
Zen mode,
making this
cost structure is a little higher.
Of course, this is the
Yes. So they're just different.
but anyway, the scale should be the same kind
It's
of
the same just a scenario where
close
you have
peak, which is when I
that
take
looks
this
like it's nice, just like F2 trace. But actually, just the F1 layer.
but so that is calculated exactly
Those sometimes use
Note, this is the bottom side scale.
often
Right? Because you only have the bottom side profile. It is then often assumed that the top side, at least close to the peak,
and of course
will be the same on the bottom and the top where you would expect. And that's actually, if you look at this profile,
it's
so
like
it draws,
auto scaling.
it draws part of the profile of the extra. That's like extrapolation, yes. So because only from here to there,
Yeah,
only the bottom side, that's where you actually anything below this frequency, you do not get any measurements. And then the entire top side, that's also like assuming that the scale has been the same on both level, and then there I am sure that it just assume chapter. So those are extrapolations. That's also why it's probably that slide to communicate that this is not necessarily to be trusted. What? Yeah. Well, it said it just the model always says there should be because the display. Okay, this is a nighttime, so you can expect to display. But of course, this is up to like 5 minutes. In reality, of course, there is always so much. It's just far too small.
That's the maximum. And
So
there's
in reality, because here it's
height of the maximum.
but in reality, that's saying
Anytime you see a line,
something virtual. Basically, yes. It's just the basically what it says. Okay, the model that is used is basically always using just like sometimes it will be so small that you don't
That's the ionosphere.
the reason that you only see from it is not that they don't have so well. So it's pretty sure that this just almost nothing. Because they know the extension low frequencies, they don't have that's probably the same. But for the fact that they're so strong, I mean, see the density exposed to the outer element of the effects. And so there we can in frequency. That can set the maximum or the minimum of others to show that the more you go down, right. But so if I put it on 4, and that's fine, you would generally see that which will also show up there. But if I put this up, it's not going to be much. It's nighttime. The original part, so the air that you get from the outside, it's like point, and then it's. You think this is even more. So it's just a whole bunch of the way that very no longer works. Full of big centers. Anything that is not getting in here. So it's just trace curvature on that side. If you cut it that way, and at that point, you would be able to kind of distribute. But most of them are quite low. So we have the down here as a smaller. Oh god, touch screens save your life. I've got a silence over there. Yes. Because otherwise you will get noise anyway. If they were big. Yeah. I have a small keyboard. This it's not a pleasure. I actually got there before. That's and it makes me feel like I'm even though I'm not. Is that a problem? Yes. So now they are supposed to so none of the house which is something like this. Yeah, sure. You just see both. God, I love that. So then the way to polarization. So then you have to know yourself that okay, the most guys will always be fixed. You get the stuff or yeah, I'm not no, so it depends on the ionosphere. Because you know this was in we cannot stop it. Because there is a where you just Denmark, no, okay. There will always be splitting signal in two by the atmosphere because there is no magnetic field. Okay. A Linux Pro in the house. Okay. Anyway, my previous is sometimes. There are some instructions. So who has yeah. So and NHCP is the NHCP it's only when it's so you can't try and slow down this line, but it will take and then it will, and in the end it will. Because, I mean, it's my experience. I suggest that you just skip the actual calculation of the power just in the scale. In the end, the scale versus the create now I also have a solution that the folder where you can save also because it's so if you go now in another I think that the moment you
How valuable is it to have some parameters?
yeah. The problem is that
You can see on his, he has some.
So you just remove one and name the image. That might be a case. And no, if you have and then
Yeah, so
It is now 20 minutes before 1, which is supposed to be lunchtime. So if anyone is interested in lunch, I don't know,
because I don't have the program here in front of me, does anyone know when the lunchtime is supposed to end? 1 hour. Okay. So I suggest that we break for lunch, and then in about 1 hour we come back, and we will continue after the lunch with still this work before we go to the final presentation by David on the more difficult cases.